Good morning, everyone. My name is Christine Nestor. I'm the Marketing Communications Specialist at Miller Ingenuity, and I'm going to be moderating today's DemoCast. With me is Matt Edmonds, Director of Technical Sales, and Adam Woyczik, Technical Sales Manager at Miller. Today, we're going to be showing you a demo of our electronic roadway worker protection system, ZoneGuard. Then we'll have time at the end of the session for any questions you have about our system. If some of you are unfamiliar with this type of technology, our system is made to coincide with your existing safety procedures and provides your track workers with an additional layer of protection to help prevent common human error factors that contribute to near misses and tragic accidents. We have two versions of our system. It can be fixed or permanently installed, so you can just simply connect to the network before you start working for the day. Or we have a portable kit that is lightweight and easy to transport to each job site. Today, we'll be focusing solely on the portable system. So again, just a quick reminder that if you have any questions come up during the DemoCast, you can look at the bottom of your screen. You might have to wiggle your mouse around a little bit. And you can click the Q&A button and submit your questions there. With that, I think we're ready to get started with the demo.
Hi, you're here with Miller Ingenuity, and today we're going to show you a little bit about our ZoneGuard portable roadway worker protection kit. Each kit comes in a self-contained case like the one you see here, and inside this kit is everything you need to set up a protection zone around your work area when you're working on the tracks. So our first piece of equipment is a train detection module. This unit weighs about 5 pounds inside of an IP65 rated enclosure. Has integrated internal sensors for detecting on-track vehicles or trains as they're approaching. And it lays directly in between the running rails and the gauge of the track with its sensors facing up. Our next piece of equipment is a train alert module. Again, also about 5 pounds, IP65 rated enclosure. The train alert module also has side LEDs and a siren to be used as an alert for workers working nearby it when the train detection module has detected an approaching vehicle. And then lastly, we have worker wearables. We've got a different color for each type of employee in your work group. The gray one here is for your employee in charge or worker in charge. This device is responsible for syncing the kit and setting up the work zone. Then we have this yellow one here is meant to be used by the watchman lookout or flagman. This device will receive alerts when generated by the train detection modules and can also be used to set off alerts if the watchman lookout would like to alert the crew. And then lastly, we just have a worker wearable. Anybody assigned to one of these wearables will receive the alerts and know to clear the track when a train has been detected. So before we take our equipment out to the track today, we're going to real quick run through the process of making sure that all of your equipment is working and to give you an idea of how the equipment is set up. So each device is powered on. In this particular kit, we have quite a number of devices. In order to set up your protection zone, you only need to pull out the devices that you need in order to adequately protect yourself. So you don't have to turn on every device every time. We'll also power on the wearables by holding power button momentarily on each, and we will wait for each to fully boot. Once each device is fully booted, the LCD screen on each device will display "Please start sync process." The worker in charge is responsible for syncing the equipment, and in order to do so, they just access the menu by hitting the up or down arrow, select sync devices, and yes. And the system will go through a sync process to sync all of the devices that are going to be used in protection to the same communication network. This allows us to do a number of things, such as monitor communication status, battery status of each of the devices being used as a fail-safe measure, so that anytime you're using this piece of equipment, you will receive an alert if there's any faults or any warnings that should be displayed on the system. So we've got our test equipment all synced here. You'll notice it gives us a network connected notification on our LCD screen, as well as a total device count of the number of devices that are synced that we're going to be using in protection. That device count should always match the number of devices that you have powered on. Our TDM here, you'll notice, is flashing. This device, remember, will be placed out in front of your work zone as far as you need in order to get 15 seconds of warning. And these blue flashing side LEDs are designed to let any equipment or train operators know that there's a work zone ahead. These do come in any color. The ones we're going to be demonstrating today are blue. Our train alert module, you'll notice all these green lights, is also connected and synced with the network, so it's ready to receive alerts from either the train detection module or from wearables that are generated by users. And then our last two devices are our other worker wearable and watchman lookout wearable. So before we take these out to the track, we just want to make sure that everything is working. So we'll quick manually generate a detection. So you'll notice when the alerts were going off, the train alert module was blasting a loud siren, as well as its flashing side LEDs to let workers know that something is approaching their work zone, as well as the wearables were vibrating and generating an audible alert. So we were able to clear that from our wearables and reset the system, so now we're ready for the next train to come by. So that's pretty much the process of setting it up and testing your equipment. Now we'll take it out to the tracks and show you how it works live. So we've tested our equipment by the truck. We know it's all working. Now we're going to run through the process of getting this equipment set up on the track and run you through a few real-world scenarios about how the system works and how it's operated. So to set the TDM in place, we're going to press the power button and turn it on, and then place it in the track facing sensor up, with the side LEDs facing down the track for any equipment or train operators to see. Train alert modules should be placed in between your train detector module locations, preferably always one near the work crew so that they can see and hear the audible and visual warnings. Train alert modules are typically spread out every 400 to 1,500 feet, depending on line of sight. We have several different mounting options. They can be placed directly on the ground. They do not need to be placed in the gauge of the rail. This is a magnetic mount that we're using today. So we have these metal catenary poles to take advantage of. So again, the process is the same as we did by the truck. We power it on and hang it from our mount, and this is all set up. So we'll place as many of these as we need in order to get the size protection zone that we need and to repeat the signal for the train detectors so that workers always receive their alerts on time and every time. We're working on the near track today. Just going to explain our setup of our worker protection zone here with our ZoneGuard kit. We have our TDM down this near track, about 1,800 feet away, around this bend. This is 50-mile-per-hour track here, so 1,800 feet, 1,900 feet gives us about 25 seconds of warning. We do have one TAM positioned on the corner of this bend to act as a repeater around that corner, so that we'll get the alert before we even see the train. And then we have a TAM located near our work zone here so that we get the additional visual and audible alerts. And then I'm outfitted with my worker in charge wearable, which will also give me alerts when the train detector positioned down the track detects the train approaching. When a train is detected by TDMs, workers will receive train alerts on their wearables. They will get a train alert message here on the LCD screen, as well as an audible, vibrating, and LED alerts here at the bottom. To acknowledge the local alert, I just press the enter button. And then once the train has fully passed the work zone, the worker in charge can reset the global alert by holding down the enter button. And they're ready for the next train. When you're finished using your equipment for the day, you quickly just desync the kit again through your worker in charge wearable. That will disarm the system. Takes about 5 to 6 seconds for the desync process to complete. Once everything has desynced, you can remove your equipment from the trackway. And put it away for the day. Once your equipment is all removed from the trackway, to store your equipment, you just put it back in the case here. Turn off each device. Slide it into the case. The wearables have a wireless charging dock that they slide into. And then each of the TDMs and TAMs have a charging cable built into the case so that they can be plugged in. And then lastly, you charge your entire kit by just plugging in this to any standard 110 outlet. We get about 4 to 8 hours recommended charging time. We'll fully charge your equipment, and then once fully charged, this whole kit will run for about 20 hours continuously around your work zone.
Okay, I hope you all enjoyed our video demo. Again, this was just to show our portable version, but most of our technology and functionality works just the same as our fixed version. And we can certainly answer any questions you have about our fixed version in the Q&A as well. So I'm going to open up our Q&A portion of the DemoCast. If you haven't submitted your question yet, just locate the Q&A button at the bottom of your screen. Again, you might have to wiggle your mouse a little bit for it to show up. And it looks like I have a few questions already in the queue, so I'll just get started. Matt and Adam, first question, how heavy is the total kit as shown?
You want to take the first one, Adam?
Yeah, the total weight of the kit shown in the video is right around 50 pounds. The devices, the detection modules and the train alert modules are just under 5 pounds, and the wearables are just under a pound. So it was right around 50 pounds for that kit.
Second question, is the warning time variable? Can it be increased depending on train speed on the line?
Yes, the warning time is variable. We always recommend that when you're placing the detectors, you look at your site chart for watchmen or your safe stopping distance when working with a flagman. So basically you put your detector out as far as you need based on the track speed you're working. We mentioned 15 seconds in the video at one point because that follows federal guidelines, but you'll notice we put the detector out far enough so that we could get 25 seconds, which gave us plenty of time to clear, to make sure we were in the clear 15 seconds before the train arrived. So really that's the main difference between our fixed system and our portable system. Is the portable system, you're responsible for putting the detector out at the necessary distance based on track speed. So there is some, a little bit of thinking involved in the setup. And the fixed system, it's permanently installed, and different track speeds at different locations are built in. So there's no guessing for where or how much warning you're going to get based on what section of track you're in.
Okay. Third question here, how heavy are the wearables?
The wearables are under a pound. They're 0.72 pounds to be exact.
Just to add on to that, roughly it's like carrying your cell phone around, a little bit thicker, not quite as wide as a cell phone, but really not much different than carrying your cell phone around in your pocket. It does have a belt clip on the back, so you don't have to put it in your pocket. You can put it on your vest or a belt or anywhere else.
How do you know where to place the train detection module, and how do you know where to place the train alert module? You mentioned the range of the equipment, so how do you know where to put them?
Yeah, quickly with the train detection module, again, as we mentioned, it goes right in the rail, and you would want to, you basically need to figure out how much warning you need to get and what the track speed is. So you put that out the necessary distance to meet that criteria. Train alert modules, just like the rest of the equipment in this, it is all wireless communication, radio, 900 megahertz radio communication. So it does require line of sight in between devices. So if you have a big bend, vertical or horizontal curve in the rail, you would want to make sure that you have line of sight in between your detector and the next train alert module down the track. And then again, we typically recommend that you put a train alert module near your work crew so they get those extra alarms. And then once you have line of sight between devices, you can spread them out anywhere in between a few 100 feet and a few 1,000 feet in between units.
Next question here. Can you secure the train detection module to the rail or ground?
We do offer mounting plates that secure to railroad ties. One of our applications, there's a crew that inspects the track at the same switch locations about once a month or once a week. And they install the tie mount plates that the TDMs go into. So they just figured out the distance that they needed, and they measured it out the first time and fixed the plates to the ties. And every time they go out there, they just install the detection modules at those locations.
Great. How many devices can be included in a kit?
Theoretically, there's not really a limit to how many devices could be put in a kit. Currently, the largest kit that we've made or had to make is about 20 total devices. Again, you really only need, if you look at your particular property that you're working on, kind of as a general guideline, figure out how many devices you may need. Most of the time it's about 2 TDMs and a couple TAMs, and depending on who you want to outfit with wearables. And we'll, provide a kind of a custom case that fits all of that stuff. You can certainly go more, you can certainly go less. We recommend to have maybe an extra TAM or 2 just to elongate the network and get a little extra warning. But again, when you're actually using the kit, you don't need to take every device that's in a kit out. Depending on where you're working and the specific protection, you only pull out the devices you need to protect yourself in that certain scenario.
Okay, next question. I heard the word fail-safe early in the demo. Has a formal failure modes and effect analysis, FMEA, been done, and is it available for review?
I would say a formal failure mode and analysis has not been done or published or anything like that. We recognize, especially with detection equipment specifically, each type of sensor and each type of a piece of equipment that's used for detecting really anything has potential failure modes, which is one of the reasons that we put multiple sensors and always different types of sensors inside of our detection modules, because any individual sensor could fail due to environmental circumstances around it. So our detection modules do use multiple sensors and different types of sensors to detect the train, which helps us eliminate, false alerts and missed detections, things like that. And just to clear that up, it is built fail-safe. So anytime there is a failure mode, we default to alerting the work crew. Different than Vital. Vital would kind of carry a few other requirements with it, but the design in the system itself is fail-safe to revert to the most restrictive or safest manner, which is warning the work crew if we detect any issues.
Is there any equipment required to go on the train?
There's no equipment required to go on the train. We we do have an onboard that customer requested, so we complied with that and installed onboard so their crane operators would also get the warning. The system does not need it though, it can run without it.
For the mobile portion, does the train module detect vibration and sound, or an installed module on the front of the locomotive?
So kind of as Adam mentioned, there's no requirement for anything to be installed on the locomotive. This has been key for properties that, like a short line that might run several different locomotive types and from different companies on their line. So we recognize that outfitting each of those trains with an onboard device is not always possible or practical. And as far as detection, one of the modes that it does detect is vibration. It also has a LiDAR, which detects the train as it directly passes it. So we use both of those. And then we have also used a radar in combination with that as well, which is very immune to weather conditions and things like that.
Is there a way to lock the TDM in place so it can't be carried off by a passerby?
Yes, the time mount plate I mentioned earlier has holes designed in it that match up with holes in the mounting plates on the back of the TDM where you can insert a padlock or any kind of lock you may have.
What technology is used for train detection? Is there any chance of detection of a train on adjacent track?
In the particular units that you saw in the video there, we were using a combination of LiDAR and accelerometer to detect basically a laser beam as the train goes by it at a specific configured distance, and then it detects the vibration as the train is approaching and as it's above it. And then as far as chance of detection on adjacent track, that's one of the reasons we use the LiDAR, because it will only detect something on the track that the TDM is placed on. So it will not detect, vehicles passing by on a nearby road or anything on the adjacent track. You can easily offer or have adjacent track protection with our system simply by placing an additional TDM on the adjacent track. And then you will get an alert to anything traveling on the track you're working on or the adjacent track next to you.
Just gonna do maybe a couple more of these questions. We have some great questions here, and I know we're running short on time. Let me just pick two more here. And then if we don't answer your question, please feel free to email us at sales@milleringenuity.com. Let me pick, where did that question go? Are the warnings from the devices captured or recorded somehow? Meaning if an accident occurred, how will you know if the warning actually provided a warning?
There are logs that we can download. Every event gets recorded on the train detection module, the train alert module, and the worker wearables. So we could download all the logs from each of the wearables to determine like time and place. It's all time stamped, time and date, I guess.
Yeah, the logging is pretty significant. We've had questions about whether or not work crews are setting the equipment up properly. So we've been asked to download the logs, and we can actually pinpoint exactly how the system was set up, GPS location within a few feet of where each device was when it was operating, and then when warnings were generated, how much warning time was provided to the wearables, when workers were acknowledging that. So the logging is pretty extensive on the system.
Where did that go? Oh, what's the battery life on the TDMs and wearables?
The shortest battery life on any of the units is the TDM itself, because it has the additional sensors. So on a single full charge, you get about 20 hours on the detection module. Where alert modules get about 30 hours of runtime, and then the wearables themselves get actually about 3 days roughly of runtime on a single full charge. We recognize that there are also instances where people may be working in a specific area for several days or a long weekend. So we do offer a battery backup that can connect to TDMs and TAMs. It can be placed outside the gauge connected with a 15-foot cable, and that gets you about an extra 2 days of runtime. So minimum runtime on a fully charged system is about 20 hours, and maximum runtime on, again, one kit is about 3 days or so.
Okay, so we have time for one more question, and we have so many more. Again, if I don't get to your question, please feel free to email the question to us at sales@milleringenuity.com. And the last question that I will read here, I just lost it. Oh, what happens if one of the workers leave the work zone?
If one of the workers leaves the work zone, the system will still function as it's intended. The worker's wearable will disconnect from the network, and the rest of the workers will receive an alert saying network lost. It just means that the one person is left, and the roadway worker in charge would then have to go in and find out why they got that message. So he's able to go into the menu and find out which device has left the work zone, and then he can track down or find out why that person left or whatever the case may be. The system will still receive train alerts for everybody that is still in the work zone. And once that worker returns, as long as they didn't shut their device off, once they return to the work zone, they will sync back in and be connected the same as all the other employees there.
Okay. Thank you, Adam and Matt. So that we did run out of time, unfortunately. As I said, again, feel free to email us at sales@milleringenuity.com if we didn't get to your questions. And also, if you get off this webinar and you think of a question, or you want to set up a call with Adam and Matt to discuss any of the details further, or even to set up a live demo on your own property, you can reach us at our contact information, which is right on the screen. You can also find us on LinkedIn. We're very active on there as well. So I'd like to thank all of you for taking the time to join us this morning, and thank you to Progressive Railroading Magazine for hosting us. And that concludes our DemoCast. Have a great day, everybody.